Hello, in this example, we're going to go over how to set up and run an NPT Ensemble in GOMC and generate the files required using MoSDeF. My name is Brad Crawford. I would like to take this time to thank Wayne State University for their support of this research. I would also like to thank NSF for the support of this research via these three grant numbers, which pertain to the GOMC and MoSDeF funding. We're going to import the Python packages we need to generate the GOMC files via MoSDeF. We're going to set the box length at 45 angstroms for the liquid box and a total number of 850 molecules. For this liquid box, we're going to use hexane and water at a 50-50 molar ratio. Run that with Shift-Enter. Next, we're going to create the water and hexane molecules, load the force fields, minimize the structures, and then name them as residues. For the hexane, we're going to use a trap UA force field, which is a standard package in MoSDeF. Next, we're going to import the file hexane mol2 file from the files folder. We're going to minimize the structure and then name the residue hex. For water, we're going to import the force field file, specifically SPCE force field, from the files folder. We're going to build the water structure using a smile string. We're going to minimize the water structure and then name it H2O. We're going to make some lists for later building the box and writing the files. First is the molecule type list, which is hexane and water, the mole ratios of hexane and water, and then how many molecules of each type is going to be put in a liquid box. These have to be integer, so this is why that INT is there. The residue names list, so all the residue names in the simulation. The bead to atom dictionary changes the force field designation to whatever you want. In this case, I just want to name them C for hexane, because that is the only UA force field here. Water being used is using an all atom force field, so there is no beads. So they will just be named H and O automatically. So this will allow the hexane to be named C1, 2, 3, 4, 5, 6. So for the force fields, we're going to specify the residue name with a force field, the residue name being a molecule here, hexane to the hexane force field, and water to the water force field. We need to fix the bonds and angles in water. So we're going to make a list here and put water's residue name in here. Should be used later. Building the simulation box. We're going to use the list of molecules we specified before, the number of compounds that we just calculated, and the box dimension. It's divided by 10 here because this function's units are nanometers. Let us run. We're going to build the charm object that is needed to write all the files, the force field, PSF, and PDB, and GOMC control files. So we just insert box 0 or a liquid box, name it for the PSF and PDB files. There is no box 1 because we're doing an NPT simulation. Name the force field file or .imp file. Use the force field dictionary that we just previously made. Use the residue list that we made, the bead to atom dictionary that we made, and the residue names for water because we want to fix the bonds and angles of water. Finally, we're going to write the force field, PSF, PDB, and GOMC control files. The first three are written here. The GOMC control file. Just put in the charm object, whatever we want to name the control file. NPT for the ensemble, 100 steps at 300K. Now, there's a lot of input variables you can use here, but I just selected one. Say we want the pressure at 10 bar. Shift-Enter. You can see it's running, telling you some information about what you selected. We're going to go through a terminal window example to run part 5A, the NPT example. So first, we're going to want to CD into the directory where the Python file is located. So we do that by typing CD and then dragging the Python file that we want to run into the terminal window. And then we just delete the file name, leaving only the directory path. Hit enter. Now we're in this directory in the terminal window. We're going to run the Python file by typing Python, start typing N, tab, and it'll fill the rest. We just type in the Python extension since it had a similar extension for Jupyter Notebook. And keep in mind that this Jupyter Notebook and Python files are the same files, just in a different format. So we hit enter to run, noting that I'm already in my environment that MoSDeF was built in. You can see these files were generated, the 4 files we need, PSF and PDB for the liquid box, GOMC control file, and the force field file. Next, we want to run the GOMC simulation. And we do that by going into the GOMC program directory. And after you build the GOMC files using the GOMC manual instructions, you get a bin directory. And in this bin directory, we want to use the NPT version. And I'm using the CPU version because I'm on a Mac and the GPU is not enabled. So to run it in the terminal window, we just click on it, drag it up, drop it, plus P2 for 2 cores. And then we want to run the GOMC control file. So start typing in tab, and it'll finish it. And then we want to specify what the log output file will be named. So we'll just name it out.dat. You can name it whatever you want. Hit enter. You can see it's building the files. It's done. Just take a look at the bulk output file to make sure it worked properly. And we can see it generated data as we expected to 100 steps. That's it for this example. Thank you for watching. Here are the references used for this work. Please note that the references for previous examples and videos are the same to keep it easy to find for the viewer.